Hello everyone. So today I'm going to talk about numericals, some of the numericals from the chapter A, optics and optical instruments. The first problem which I have considered is based on prism. So the problem says a prism of refractive index 1.6 produces a minimum deviation of 40 degree. Find the angle of the prism. So here they have given the refractive index of the prism, that is 1.6, and then they have given the minimum deviation, that is 40 degree, and then you need to find out the value for angle of the prism, that is A. Okay, so do we know the formula for it? Yes, we know the formula for refractive index of the prism. So that is n equals to sine of A plus D divided by 2 whole divided by sine of A divided by 2. Okay, let's substitute the values. It becomes 1.6 equals to sine of, we don't know the value for the angle of the prism, we'll keep it as it is, plus deviation we know, that is 40 degree whole divided by 2, then this divided by sine of A by 2. Can I directly write this way? So can I take it here? Yes, I'll take this one here. So I'll write it as 1.6 sine of A by 2 equals to sine of A plus 40 degree divided by 2. Okay, so can we write this as sine of A by 2 plus 40 degree by 2? It becomes 20, right? Sine of A by 2 plus 20 degree, right? Can we write it this way? Yes, we can write it this way. So I'll directly write it. So this becomes sine of A by 2 plus 20 degree, right? So we'll keep this one as it is. Okay, when you look at this, is it in the form of sine of A plus B? Yes, it is in the form of sine of A plus B. So what is sine of A plus B? Sine of A plus B can be written as sine A cos B plus cos A sin B. So we'll also write it here, sine A cos B. So in the place of A we have A by 2, in the place of B we have 20 degree. So plus cos A is A by 2, sin B is sin 20, right? Okay, so we'll keep this one as it is, right? So if you notice, here also you have sin A by 2 into 1.6, here also similar thing you have sin A by 2 into cos 20. So when you take this part here, it becomes negative. So it becomes 1.6 minus cos 20 degree into sin A by 2. Why? Because sin A by 2 is common in both, right? So you will take sin A by 2 common and you will keep 1.6 minus cos 20 degree in the bracket, right? Next is, rest of the value is cos A by 2 sin 20 degree, keep it as it is. Okay, I'll write here. Okay, so now this part, this 1.6 minus cos 20 ಏನಾಗುತ್ತೆ, take this part on the other side, it goes to the denominator, whereas this cos A by 2 comes here and it comes to the denominator. So here it becomes sin A by 2 divided by cos A by 2, which equals to sin 20 degree divided by 1.6 minus cos 20 degree. Okay, right. Here sin divided by cos ಏನಾಗುತ್ತೆ, sin divided by cos, sin theta divided by cos theta is nothing but tan theta. So tan A by 2 I think. So tan A by 2 equals to sin 20 divided by 1.6 minus cos 20. You can substitute the value of sin 20 degree, and also you can substitute the value of cos 20 degree with the help of a log book. So when you substitute the values, what value do you get? So I am getting the value 0.518. Okay, so you also calculate and get the value for sin 20 degree divided by 1.6 minus cos 20 degree. So here A by 2 equals to, tan goes to the other side, it becomes tan inverse of 0.518. Okay, so again get the value for tan inverse of 0.518. What is the value? So you will get 27 degree 23 minutes for A by 2, but we need the value for angle of prism, that is A. So A equals to 27 degree 23 minutes into 2. So this 2 goes to the other side, and it multiplies with the value of A by 2. So here now the value of angle of prism will be 54 degree 46 minutes. Okay, so this is the value for angle of the prism. So I hope you have understood. You will get the similar kind of problems in the exam. So let's move to the next problem. Thank you. So the next question says, a prism having refractive index 1.414 and refracting angle 30 degree has one of the refracting surfaces silvered. A beam of light incident on the other refracting surface will retrace its path. What is the angle of incidence? So here you need to find out angle of incidence. Let's write down what all they have given. So they have given the refractive index of the prism, that is 1.414, and then there is refracting angle is nothing but angle of the prism. So I'll write it as A equals to 30 degree. So has one of the refracting surfaces silver. Well, we'll draw the diagram of the prism for a reference. So here is the prism. Let's say this is the prism. Okay, so a beam has one of the refracting surfaces silver. So all are refracting surfaces here. One of them is silver. So here let's say this is silver. That means here now since it is silver, it cannot refract, it will reflect back. Okay, now so a beam of light incident on the other refracting surface. Let's say there is a beam of light which incidents on the other refracting surface, and let's say this is the normal. Okay, and here is the angle of incidence. I hope you can see it. Should I draw it a bit? Okay, let's see, this is the prism. Here is the angle of the prism, that is 30 degree which they have given, and one side of the prism, one of the refracting surface is silver, so it acts like mirror now. Okay, if the ray incidents on this particular surface, it will reflect back. Okay, there will not be any refraction. A beam of light incident on the other refracting surface. Let's say here is the beam of light which incidents on this refracting surface, and let's say this is the normal. Here will be the angle of incidence which you need to find out. So when the incident light incidents on the refracting surface, it gets refracted. So here it gets refracted and it incidents on the other refracting surface. But what happens, since it is silver, it cannot refract, it will reflect back. That's what they are saying. Okay, so the other refracting surface will retrace its path, so it will reflect back in the same path. Okay, so there is only one refracted ray now. Okay, angle of refraction is only one. So and we have a formula for angle of the prism. that particular formula is A equals to R1 plus R2. Do we have R2 here? No, we don't have R2 because we don't have the one more angle of refraction. So one more refractory we don't have. So there is no R2. So R2 here is 0. Okay, R2 is 0. So A equals to R1. What is the value for A? So A can be written as 30 degree equals to R1. So basically what is the value of the angle of refraction here? So angle of refraction becomes 30 degrees. So you got the value for angle of refraction. Okay, you need to find out angle of incidence. So you have refractive index value as well. So can we consider Snell's law formula? Yes, we can consider Snell's law formula. It says n equals to sin I divided by sin R. Okay, sin I divided by sin R. N is 1.414 into sin 30 degree equals to sin I. Okay, so I'll rearrange it. So it becomes sin I equals to 1.414. What is sin 30? What is sin 30? Sin 30 is nothing but 1 upon 2. Right? Sin 30 is 1 upon 2. What is 1.414? 1.414 is nothing but root 2. Right? So can we write it as sin I equals to root 2 into 1 upon 2. 1 upon 2. 2 can be written as root 2 into root 2. Right? So 2 is nothing but root 2 into root 2. So root 2 gets cancelled out. You are left with sin I equals to 1 upon root 2, that is I equals to sine inverse of 1 upon root 2, which is nothing but 45 degree. So what is the angle of incidence here? The angle of incidence here is 45 degree. Okay, so I hope you have understood. We'll meet in the next video. Thank you.